Good morning. Now we are discussing a topic, polarization by selective absorption. This is one of the method of producing plane polarized light. Certain crystals, the two doubly refracting crystals, they can absorb ordinary and extraordinary rays unequally. They have the ability to absorb the ordinary ray and extraordinary ray unequally, and this property is utilized in order to produce plane polarized light. So this phenomenon is called selective absorption. We pick the crystal in such a way that one of the rays is completely absorbed, whereas the other ray is allowed to pass through. Hence the name selective absorption, or otherwise known as dichroism. The crystals which exhibit such a property are called dichroic crystals, Let us consider an unpolarized light. If such an unpolarized light is incident normally on a dichroic crystal of proper thickness, then one of the components will be completely absorbed. One of the components of ordinary and extraordinary ray will be completely absorbed, whereas the other will be allowed to pass through the crystal. Example, if we consider a tourmaline crystal of around 1 millimeter thickness, it can completely absorb the ordinary ray and partially absorb extraordinary ray, whereas it allows the remaining extraordinary ray to pass through. Now, Polaroids. In Polaroids, we study what are Polaroids, how they are produced, and its applications. And these Polaroids are nothing but sheets of doubly refracting dichroic materials. Polaroids are dichroic in nature, in the sense they can completely absorb one of the rays to produce plane polarized light. And these Polaroids were first developed by Edwin Land in the form of a thin sheet of nitrocellulose. He developed these Polaroid films in the form of thin sheets of nitrocellulose packed with iodosulfate of quinine, also known as herapatite. And they are arranged in such a way that their optic axis will remain parallel to one another. The optic axis of all these crystals will remain parallel to one another. And each Polaroid will have a characteristic plane. So along such characteristic plane, the complex molecules will themselves align. And such a plane is called a transmission plane. The characteristic plane is called a transmission plane, along which the complex molecules are arranged themselves. And this transmission plane is represented by drawing lines parallel to one another on the Polaroid film or on the Polaroid sheet. And the vibrations parallel to these lines will be transmitted, whereas all other vibrations are filtered off, are not allowed to pass through otherwise. Now coming to the types of Polaroids. We have two different types of Polaroids based on how they are produced. We have H Polaroid and we have K Polaroid. This H Polaroid is a thin film of polyvinyl alcohol subjected to strain with iodine. When a thin film of polyvinyl alcohol is subjected to strain with iodine, we get H Polaroids. And when these H Polaroids are heated in the presence of a dehydrating agent, then it becomes permanently doubly refracting, and such permanently doubly refracting Polaroids are called K-Polaroids. And these two diagrams represent the Polaroids, the thin sheets of nitrocellulose packed with iodosulfate of quinine. So you can see the lines parallel to one another, and these lines are called the transmission lines or the transmission plane. In the first figure, both the Polaroids are parallel to one another, and in the second figure, the transmission planes of both the Polaroids are perpendicular to one another, and therefore this area is blocked. No light will pass through this area, and hence it is black in shade, right? Whereas in the first figure, light parallel to this transmission plane will be propagated, whereas in the second figure, light parallel to the first Polaroid, light parallel to the transmission plane of first Polaroid is propagated in this way, whereas light parallel to the second Polaroid is transmitted in this way, whereas in the crossed position, no light will be propagated, no light will be transmitted in this area. Now coming to the uses of Polaroids. We have multiple uses of Polaroids, among which we are studying only few. And these Polaroids are used to produce and analyze the plane polarized light. The first application used to produce and analyze plane polarized light. They are used in the manufacturing of sunglasses, the Polaroid glasses. They are used to view the three-dimensional pictures, 3D goggles or otherwise. And these Polaroids are used to improve the color contrast of old paintings. Old painting color contrast can be made. To study the optical properties of metals, we make use of these Polaroids. To control the intensity of light entering the trains, aeroplanes, etc. can be controlled by making use of Polaroid window sheets. To eliminate the headlight glares, we make use of these Polaroid sheets in the windshields of automobiles. And to eliminate the glare of reflected light in cameras, they make use of filters as Polaroids. They make use of Polaroids as filters to eliminate the glare of light in cameras. So these are the few applications of Polaroids. This is about Polaroids. Thank you.